خلاص. I will pass through all of you one by one directly. Rana, you talked about what, Rana? Tell us in brief, in 1 minute.
Okay. We discussed the proposed technique of using the vibrating barriers to mitigate the seismic effect on wind turbines. Okay, can you hear me?
Okay, yes, yes.
Okay, we passed through the generating the data set, modeling the turbine, modeling and validation the turbine, then generating the data set. Then we verified that the vibrating barrier technique can reduce, can make a very good reduction of the turbine acceleration as a response reduction. Then we discussed the used neural network and the network architecture. After this, we go through the results. We show the results of different data set training to validation ratio and the effect of this on our results.
Okay.
We also discussed the criteria of the VIBA design using neural network.
Okay. Okay. In short, also, I would like Ibrahim Hassan to tell us in 1 minute only. Your talk was about what?
Hello, everyone. Can you hear me?
Yes.
Okay. I talked about the utilization of CFD for high-rise structures and how we can use modeling for the high-rise structure in order to predict the wind pressure along the elevation of the structure in the windward facade and leeward facade. In addition, the CFD can give us insights on how vortices can be developed due to the wind effect and how these vortices can affect the crosswind forces across our structure if the frequency of these vortices matches the natural frequency of the structure. So in briefly, modeling of CFD allowed us to model different scenarios for the wind that could affect as a lateral load of the structure, as well as the phenomena of the variable induced vibration. That's it.
Okay. Okay. Dr. Kamal, can you tell us in brief, 1 or 2 minutes, your talk was about what?
Talk about the transient computational fluid dynamics problem in 2D and an introduction to the 3D. Where we solve the problem using the meshless method fundamental solution and using the penalty formulation. We talk about how to deal with that inertia term using the time differencing technique, and how to solve the problem using meshless method fundamental solution. Then we give an introduction for the 3D case and how to deal with that domain integral using Monte Carlo technique.
Okay. Okay, great, Kamal. Taiko or Ahmed Mahmoud Mustafa Hassan, can you give us a brief about your talk?
Can you hear me?
Yes.
Okay, my talk was about finding the source location for the method of fundamental solution. So the method of fundamental solution is this numerical method that requires a source point placement around a problem domain. So first of all, we divided this method of fundamental solution scheme into two parts. The first part is a preprocessor, where you find the solution at boundary points. For example, for elasticity, you get any unknown boundary point value in terms of traction or displacement. After this, we utilize this result in a post process The post processor solves the problem to calculate any required information in the domain. So the first part, the preprocessor, we optimized the source location using a genetic algorithm scheme where we programmed the genetic algorithm to generate the source point location, and then we utilized the effective condition number to as a measuring parameter to evaluate the behavior of the numerical scheme or the effectiveness or the accuracy of the solution. Actually, we first correlated the accuracy of the solution with the effective condition number before we started this process. And then after we find the optimal source location for the preprocessor, we then use the now known boundary values after the first solution to further optimize the source location for the post processor to evaluate the domain terms or to evaluate the domain terms or the domain values that you want to know in terms of displacement and traction as well.
Okay.
We utilized two types of artificial neural network for the scheme. The first type was a supervised artificial neural network, and the second type was an unsupervised artificial neural network. The supervised one, we used a data generator to place the source points in a random manner, but in thousands of iterations, and then for each trial of the source, for each setting of the source point location, we evaluated the error for this specific point distribution. And then we repeated that for thousands of times. We collected a data. The data set consists of a set of point location and their corresponding error. We train an artificial neural network using this error point location array by feeding the network. The input was the error value, and the output was the location array. After this network was optimized, then we set the error parameter to 0, and then we see how the network would generate the source location, the best source location that would
From your
actually
opinion,
produce.
which one would be much better, the supervised one or the unsupervised one?
The supervised one for now is of course is much better because all its parameters are controlled, or its parameters are under control, and we know exactly how the network would behave. But the unsupervised one, we according to the learning curve, it's not stable or smooth during the learning process, but it is learning. The loss function decreases with iterations.
Okay,
It does happen.
It needs some sort of analytical condition or something like this.
I think more fine tuning to the current parameters would actually yield a pretty good result.
Okay, let us see. Okay, thank
Let
you.
us see.
Thank you. Haitham,
you.
can you give us in 2 minutes your talk about what?
I'm going to talk about optimizing pre-stressing profiles and area in box girder bridges, where an application using C# code was created to generate a large amount of data set used to train different neural networks, carrying out parametric studies to optimize the architecture and the type of network used, in which the final trained network will be used in a genetic algorithm optimizer to find the optimal pre-stressing area and its corresponding layout. The optimal pre-stressing area means the minimum one, which eventually reduces the cost of the bridge.
Okay, thank you, Haitham. Ala is with us, or Fadi can, Dr. Fadi. Ala
is
with us, or
yes, Ala with us.
Or you'd like to talk on her behalf? Okay, let us go to Abdurrahman Kamal. After that, come back to Ala. It's not a problem. Okay, Abdurrahman, can you give us in 2 minutes your talk was about what?
Yes, we are talking about vibration behavior in tension concrete slabs. As simple example, as we use regular slabs. Our objective is to study the vibration analysis, frequency and acceleration on practical examples. We started with the simple examples, which is in the previous researches, like regular slabs, and we use boundary element in our method. The results we get to till now is for frequency is like the experimental studies and compared with finite element using Abacus software is approximately the same using 2D model, and we are now in the acceleration with respect to the previous research, but we are making this on a practical example. We will make this on practical example.
Okay, thank you, Abd. Ala is going to give us brief talk, or she is not with us. I think I can see a
Can you
mobile.
hear me?
Okay, go ahead, Ala. 1 or 2 minutes about your talk about what?
I'm talking about a new formulation developed using the meshless method of fundamental solution with a time-stepping fundamental solution to solve two-dimensional elastodynamics problems. For the domain integral is treated using the Monte Carlo integration technique to achieve fully meshless formulation.
Okay. Do you have any suggestion for the selection of the source point or the number of used Monte
For the
Carlo
printing,
or something like that?
I've tried many meshes for each number of nodes, offset distance, number of internal points, values of delta t, and this is shown in the presentation. I think I need more trials to set range for each parameter.
So are you planning to achieve a certain range for a stable solution?
Yes.
Okay. Thank you all for your talk. If you have any discussion among you, I will be pleased to hear. If we have nothing, we can finish now. Has anybody want to ask about anything? Dr. Kamal, Dr. Fadi?
No, thank you, Doctor.
Taiko, Haitham, Rana,
Thank you, Doctor.
Rahman, any of you? So now we can say, Ibrahim, do you want to ask about anything?
Thank you, Doctor.
Okay, so now we can say we finished our workshop. Thank you for all your participation. Thank you very much.